Hello, everyone. Now I'm going to do several problems from section 5.5, and I want to start with a problem that kind of explains why I do U-substitution the way I do it. Maybe there's a lot of people who don't do it my way, but let's start with this problem here: 2x 1 plus x squared square root of 1 plus x squared dx. Okay, this is a good example that kind of shows why I do my U-substitution the way I do it. Okay, so if I was looking at this problem and I wanted to do a U-substitution, I have one function nested inside of another. That's usually going to be my U. And so I say U is equal to 1 plus x squared, and then I need to figure out what my du dx stuff is. So I sort of do my pseudo differentiation on both sides of this. So U becomes du, derivative of 1 plus x squared. Well, that's 2x. And then I have a dx on the end. Now, the way I do it is I have this third step here where I say, okay, du is du over 2x equals dx. Okay. That's maybe something I do, and other people do it, but I don't think it's necessarily standard. And it's not even necessary in this problem, right? This, let's see, since what I have out front is just perfectly this, I could kind of rearrange my problem. Okay, like this. And then this would be my u inside the square root. And then this stuff here is just this. So I just do a straight substitution. Okay, 2x dx is equal to du, so I just replace this with du. Okay, and it's fairly straightforward. All right, but my third step helps when this stuff out front is not perfectly the derivative. Okay, so let's say instead of 2x dx, let's say we just had 1x out front. Okay, and let's try and solve this through U-substitution. My u would be the same. And then my du equals 2x dx still. And then I would try and make my U-substitution. Okay, let's kind of rearrange the problem a little bit. So I replace 1 plus x squared with u. And then what do I sub in for x dx? Because now du equals 2x dx. How does that relate to this? Well, maybe it's clear that we have 1/2 du, but my third step really makes this, it really saves us some critical thinking, I guess. It makes the thought process a little bit easier. So I get dx by itself by dividing both sides by 2x. And then I don't even have to think about, I don't have to use any hard logic here to figure out what my substitution is. I just say, okay, well, dx equals du over 2x. I leave the x where it is. I replace dx with du over 2x. The x's cancel. I can bring that 1/2 outside to get this this indefinite integral, which I can then solve. And then undo my substitution. To get this antiderivative. So I just wanted to do this problem to show why I do this third step here. Okay, I think it saves us a lot of trouble. Okay, Now let's continue on with problems from the book. How about number 10? So sine of t, square root 1 plus cosine of t. Again, I have this function nested inside of another, so that's my hint that maybe I should use that as my u. So I let u equal 1 plus cosine t. Differentiating both sides, what do I get? And then I'm going to do my third step here. Okay. Now let's go ahead and make our substitutions. So I'm saying u is equal to 1 plus cosine, and dt is equal to du over negative sine t. So plugging in all my stuff for my substitutions. Okay. So I have sine of t here, and then I'm dividing by negative sine of t here. So the signs should cancel, and I should just be left with a negative, which I bring outside. And then I'll have this. Undoing my substitution. I have this. Final answer. Number 24 is a good one, and it's one of these tricky examples we might see on the homework, or at least has the same principle as these tricky problems. Let's say I have x square root of x plus 2 dx. Okay, I'm trying to integrate this. Let's go through our typical u substitution. All right, if I have one function nested inside of another, so that gives me the clue that maybe u should be this x plus 2. But if you go through this, you can try it on your own. When you make your if you just do a straightforward u substitution and say, okay, du is equal to, let's see, du is just equal to dx, and then, okay, there's no third step here. It would be du over 1 equals dx, so just du equals dx. If we tried our u substitution, this x wouldn't cancel, right? I'd have x square root of u du. How do I deal with this? Remember, you can never have this in this Calc 2 course. We can never have two different variables inside the same integral. In Calc 3, maybe you'll see how to do something with multiple variables, but not in our course. Okay, so this is a hint that we've done something wrong. Okay, we have x's and u's in the same integral. Not good. So how do we deal with this? Our first step is still correct. Okay, so I would say when you have this nested function, the stuff inside should still be your u. Okay, but then if you have one of these problems where your stuff outside doesn't necessarily cancel, what I would do is I would try and rewrite the stuff outside in terms of u. Okay. So I'm saying u is equal to x plus 2. Okay. Then note that u minus 2 is equal to x. Okay. And then I still have du equals dx from differentiating this line. Okay. So now I have these three pieces of information. Okay. So let's try and make a substitution now. Okay. So I got my integral sign. From this line, I know that x is going to be equal to u minus 2. So let's just replace x with u minus 2 here. And then I have square root of u du. Okay. Has this helped me? Yeah, because I can just distribute this square root of u. Okay, so u times square root of u, that's u to the 3/2. Then I got minus 2 u to the 1/2 du. And now I can integrate this, right? Okay. So I get this antiderivative, and then I just undo my substitution. What did we say our substitution was? X plus 2. So this should be our final answer. So a little trick when dealing with these tricky problems where this stuff outside doesn't necessarily cancel all the way. Okay, now let's talk about the homework problems a little bit. So if you look at the homework for section 5.5, the first few problems are about composition of functions, which I didn't talk too much about in the lecture video. It's usually not covered too in depth in Calc 2. Yeah, we need to make sure our functions are always defined, but we usually kind of ignore that part in this course. But it's on the homework, so let's briefly talk about how to do these. So I'll tell you the problems in front of me, and you probably have something similar on your homework. So we're given f of x equals 8 over x, g of x equals x over x plus 8. And then we got to deal with composition of functions. We got to find f of g of x. Okay, and remember, this is this open circle. That's not multiplication, that's composition. Okay, so first we're told to find f of g of x. So how do we do that? I take g of x and I plug it into f. Okay, another way to think about this is I'm going to start writing my function f, and then everywhere I see an x, I'm going to replace that x with my function g of x. Okay, so I start writing my function f, which is 8 over x, but instead of x, I'm going to write the function g. And then I'm going to simplify. Okay, 8 over x plus 8. That's equal to 8 x plus 8 over x. Equals 8x plus 64 over x. And then, so this is the first part of the question. We'll call that A. B is find the domain of f of g. So you might be tempted to look at this f of g and just say, well, as long as x is not equal to 0, we're fine. So you might think that the domain would just be this. But this is actually incorrect. When we're dealing with composition of functions, okay, and the order matters here. If I have f of g of x, what do I need? I need x in domain of g and I need g of x in domain of f. All right, so we need x in the domain of g and g of x in the domain of f. Okay, so what do I mean by x needs to be in the domain of g? Well, let's look at, we'll rewrite g down here. So what was g? G was x over x plus 8, I believe. Let's just double check. Yep. Okay. So we need x to be in the domain of g. So let's see. What's the domain of g? Domain of g would be everything except negative 8. Okay, so let's say x does not equal negative 8. And then we need g of x to be in the domain of f. Okay, well, remember, let's see, f of x equals 8 over x. So first of all, what is the domain of f? It's everything except 0, right? We can't have, in this, we can't have x equals 0. Okay. So we've said, okay, x can't be negative 8. And then g of x needs to be in the domain of f, meaning g of x, x over x plus 8, can't be equal to 0. So this is just kind of an intermediate line, okay? We want g to be in the domain of f, meaning x over x plus 8 cannot be equal to 0, okay? All right, well, what does that tell us about x? X, let's see, x cannot be 0, all right? The only time x over x plus 8 is going to be 0 is if x is 0, okay? So we conclude that x can't be 0. So we have these two conditions. X cannot be equal to negative 8, and x cannot be equal to 0. Okay. So our domain is going to be everything except negative 8 and 0. So we would write that look like this. Okay. Let's try part C. Okay. So part C would be to find, so we found f of g before. Okay. Now let's find g of f. Remembering that f is equal to 8 over x. G is equal to x over x plus 8. Okay. So now I'm going to start writing my g, but instead of x's, I'm going to write my function f. Okay. And then I'm going to simplify. Okay. So let's see, 8 over 8 plus 8x. I can cancel out an 8, and I end up with 1 over 1 plus x. So this is my g of f. Now, again, you might be tempted to say, well, the domain is everything except negative 1, but that's not quite right. All right, so let's think about what we need now. So again, I said order matters. So this time we need x in domain of f. And then we need f of x in domain of g. Okay, so let's see what that means. Recall f is 8 over x, g is x over x plus 8. So let's see, we need x in the domain of f, so that means x can't be equal to 0. We need f of x in the domain of g. Well, domain of g is everything except negative f, excuse me, everything except negative 8. So we have 8 over x cannot be equal to negative 8. Okay, so what does that mean? Let's see, let's solve for x. Okay. So x cannot be equal to -1. All right, so let's combine these two statements. X cannot be equal to 0 and x cannot be equal to -1. How do we write that? Negative infinity to -1. Just like this. So negative infinity to -1, union -1 to 0, union 0 to infinity. The other two problems or other two parts of problem 1 are similar. It's just f composed with f and g composed with g. Same principles. Number 2. So now we're given a function we're trying to figure out what it's the composition of. Okay, so we're given this capital F of x equals x minus 4 to the power 7. Okay, so what is this the composition of? I'm trying to find, I'm trying to write this like little f of g of x. Okay, so what's my f, what's my g? Think about the nested functions we've been using in section 5.5 for U-Substitution. Okay, so in U-Substitution, we were looking for functions inside of functions, right? So we're doing this. It's the same thought process here. What's the function inside the function? Okay, so let's see. I have x minus 4 here, right? That's a function, and it's inside this larger function, blank to the power 7. Okay, so let's call g of x this x minus 4. And then f of x, the function it's inside, well, that would just be, I'm going to replace that blank I said earlier with x, just x to the power 7. Okay, so it looks like my answer should be this, and we can double check that by doing our trying to recreate this f of g of x, okay, using these two functions. So let's try that using my same logic as before. I'm going to start to write my function f, but instead of x, I'm going to write my function g. Okay, so instead of x, I write x minus 4, and then I raise that to the power 7. Is that what I had in my original? Yeah, okay. So it looks like my g of x should be x minus 4. My f of x should be x minus, x to the power 7. Number 3 is the same thing, just different functions. And then we have, then we get into our U-substitution in number 4. The U-substitution problems on the homework aren't too bad. What I'll say about, let's see, there's some tricky ones just from maybe identities and splitting up the integral, things like that. Number 9, what I have is sine of 2x over sine of 2x over 48 plus cosine squared of x. Well, how do we deal with this? I got sine of 2x here. No matter what U-substitution I do down here, the derivative of cosine squared, well, that's not going to give me sine of 2x. So this 2x seems to be a problem. But we can use a handy little trig identity. Let's see. I believe this is correct. You can double check me on this, but it should be sine of 2x should be 2 times sine of 1x cosine 1x. Okay, I believe that's correct. So let's first, before we even do a U-substitution, let's just rewrite sine of 2x like this. Okay. Then can we do a U substitution on this problem? Let's see. I got cosine down here. Okay, maybe I should do U equals cosine of x. Okay, let's see how this plays out. Du would be negative sine of x dx. Okay, let's go ahead and make our substitution. Let's see, instead of cosine of x here, let's see, I said u was equal to cosine of x, so I'm going to write u there. Oh, and instead of cosine there, I'm going to write u squared. And then instead of dx, I'm going to write du over negative sine. Okay, so the signs cancel. The negative sign is left over. I'm going to pull out the 2. So I got negative 2 integral u over 48 plus u squared du. Has this helped me? Well, maybe it doesn't look like it. How do I integrate that? We could do another substitution. Okay, so multiple substitutions. So now instead of u, let's use v. Okay, so let's say v equals 48 plus u squared dv equals 2u du. And so dv over 2u equals du. Okay. Oh, there's no negative here. So I end up with this, negative 2 integral u over v dv over 2u. Well, let's see. The u's cancel. I got 2 here, which I can pull out of my integral. And then I have dv over v. Okay. Can I integrate this? Yes. 1 over v, the integral of that. Well, let's simplify this first. I have the 2's cancel here. So I got negative integral dv over v. The antiderivative of that would just be negative ln absolute value of v plus c. Now let's undo my substitutions, both of them. Okay. So first I had v is equal to 48 plus u squared. And then u was equal to cosine of x, I believe. So I should end up with this. So a little bit tricky. But just take it step by step and use U-substitution twice. And there might be other ways to do this, but this is how it pops out to me. Okay. So I'd say that's fairly tricky. Number 10, I probably won't go through completely, but let's say 2. We got 2. What I have is 2 plus 5x over 1 plus x squared. Okay. The first thing I would do is split up this fraction. I could rewrite this as 2 over 1 plus x squared plus 5x over 1 plus x squared. Then I would integrate these things separately. It's fine to think of this integral like this, as 2 separate integrals. Okay. So this integral should just be a tan inverse. I pull out the 2 and write that as 1 over 1 plus x squared dx. Well, the integral of this is tan inverse, or arctan, whatever you want to call it. Okay, so that one I don't even need a substitution for. And then this one, I could do a U-substitution. I'll do U equals 1 plus x squared. Okay, and then I'll let you guys do the rest of that. The only tricky thing about this is a pretty standard U-substitution. The only trick is to split up the integral. Number 11 is one of those problems we talked about before. Let's see, we have x cubed, x squared plus 23. Okay, so my instinct would be to say u equals x squared plus 23. Okay, and then du equals 2x. Okay, so let's say I try that, and I should end up with, let's see, x cubed square root of u du over 2x. Okay, and then I try and cancel the x cubed here with the 2x here. Well, only part of it cancels, right? I'd have a 1/2 that I could bring outside. I'd be left with an x squared, square root of u du. What's going on here? This is not good, right? I have x's and u's in the same integral. Going back up to our original substitution, u equals x squared plus 23. So u minus 23 equals x squared. So I can rewrite this x squared as u minus 23. Then I have square root of u du. Okay. Then you guys can take it from there. And then it looks like everything else is fairly straightforward. So I will let you guys figure out the rest on your own. All right, hopefully this has been helpful. Let me know if you have any questions.